All right, hello once again, Jeff Scott of Rankin Technical College. And as part of the Rankin Technical College AWD or Application and Website Development 1100-1100 C# programming class for this summer 2023 semester, I've been doing a series of fairly simple videos. Again, simple is a relative term, based on the textbook we're using for the class, and that textbook is Murachs C# 8th edition. I've done the first 17 of 22 chapters, which means I'm on chapter 18 right now. As it says in this chapter, we'll learn about a feature of C# called link. And link allows you to do a lot of things in a very different way, and we'll take a look at it. This chapter, as it says, will focus on using link with in-memory data structures like arrays and lists. All right, but you could use other things as well. When we get to chapter 20, we'll use link with databases. All right, so we will go over some basic link concepts, how to code query expressions, how to code method-based queries, and then we'll look at an application that actually will use some link in it. All right, so let's get started. And what I want to do too is just show you there are all sorts of, if I come out here and type in link, how about this? C# link tutorial. There's going to be a lot of stuff that's going to come back. Udemy has a class, link tutorial, basic link with C#. Here's the best one though, probably. All right, introduction to link queries from Microsoft.learn. All right, and there's going to be quite a bit of stuff in here. There'll be a lot of examples, and you'll notice as you work your way down, there's a lot of different stuff in here. All right, plus they will go into the different ways you can use link to objects, link to ADO.net, some of the stuff that we'll look at toward the end of the textbook. And this class, look, basics of link with C# for beginners, and it says it's a free tutorial, an hour and 16 minutes in length. You know what? I'm going to look at it. It says go to course, which means I've already signed up for it. Let's hear the voice of the person giving the course.
Hi, my name is Todvachev, and I will be your.
Doesn't sound bad. All right, if I go to the course here, all right, you can see I've already gone through earlier at a different time, not today, and went through the introduction. But basic link query syntax, basic link method syntax, basic grouping with link, basic joining with link. This is all stuff we're going to be going over. All right, this directly or stuff like this. Okay, and I am going to go back.
Welcome also to create
Oops. I'm going to go back and rewatch that. There are a total in here of what? 14 lectures. So each lecture, hour and 16 minutes. It's about 5 or 6 minutes long on the average. Okay. All right. So LINQ is an acronym that stands for Language Integrated Query. It allows you to use query-like operations on databases and things that are not databases. That's what makes LINQ special. You can run database-like operations, for example, on arrays. All right, LINQ is implemented as a set of what are called extension methods. All right, because these methods can only be used in a query operation, they're called query operators. Although you can call them directly by coding a method-based query, you can also use the clauses. We're going to look at all of this stuff. Those clauses are presented on the next pages, the ones you're going to use most often. Some of these are going to, for lack of better words, almost be repeated because in the next chapter in the book, in chapter 19, we're going to start talking about databases. The last 4 chapters in the book are all about databases. All right, so when we look at this, okay, now let's pretend for a second that I had a table, all right, and I had a table, and I wanted to print out all the states in the table that started with W. Don't ask me why. But I would say something like select star from, let's say we had a table called states. The things I'm typing in caps are keywords. So where, I would say something like state name, like, and it has to start with a W, but it can have anything after it. That's what that would do. That literally is a relational database management SQL statement right there. However, if I was writing this as a link statement, it would be something more like from states, where state name like W, and this may not be exactly correct, but it's pretty doggone close. Select star. So you can see how it differs. All right. It's not backwards, but instead of doing it 1, 2, 3, we're now doing it as 2, 3, 1 as far as the order goes. So why do you want to do this? What are the advantages of link? All right. The first one, as it says, it makes it easier for you to query a data source by integrating the query language with C#. So basically, LINQ is designed to work with languages like C#. LINQ is a Microsoft tool designed to work with Microsoft languages. LINQ makes it easier to develop apps that query a data source by providing IntelliSense. Also, compile time syntax checking. So if you spell something wrong or whatever, debugging support. Next, it makes it easier for you to query different types of data sources because you use the same syntax regardless. Finally, it makes it easier for you to use objects that work with relational data sources by using an object relational mapping framework. If you don't know what that means, stick around for chapters 19 through 22. All right. So as mentioned here, LINQ provides a set of query operators used or are implemented using extension methods. You can work with LINQ by calling these methods or by using C# clauses. We're going to hit on all this stuff. A query that uses LINQ methods directly is called method-based. One that uses these C# clauses is called a query expression. To use LINQ with a data source, the data source must implement the IEnumerable T interface, or another interface that implements that one. A data source like an array or an array list can also be used with LINQ. And again, that's one of the things that makes LINQ so powerful. Now, the next page in just a moment presents the 3 stages of a query operation and lets you know what happens during each stage, in this case, using an array. Stage 1, as it says, you get the data source. How you do that depends on the type of data source you're working with. We're using an array. So getting the data source means defining an array named numbers and assigning values to its elements. The second stage, as it says, is to define the query. The query in this case identifies the data source, which is the array, and the data, which is the data inside, to be retrieved from that source. It says, don't worry right now if you don't understand the syntax, because we're going to be working with it. All right. Notice here that the query expression is stored in a query variable. That's necessary because this query is not executed when it's defined. All right. Also notice the query variable isn't declared with an explicit type. Rather, it's given a type based on the type of elements it will return. For this to work, we already mentioned this. The data source must implement IEnumerable or IEnumerable T or something that implements that. Then your third stage is to execute the query. In this case, as it says to do that, and you quite often do it this way, you'll use a for each statement. All right? Because typically you'll have more than one thing returned. When a query is defined and executed separately, as shown in the example, the process is referred to as deferred execution. If a query is executed when it's defined as having immediate execution. Immediate execution, as mentioned, typically occurs when a method that requires access to the individual elements returned by the query is executed on the query expression. So these are the three stages. Get the data source. Well, there's the data source right there. We've got a new array right there called numbers. We know it's an array. It's an array of integers, and it contains 5 values. Those values being 0, 1, 2, 3, and 4. Next, define the query. Well, again, there it is. From number, which was a variable we're just creating in numbers, so for a number in the array, so that'll loop through it, where the current number modulo 2 is equal to 0, all right, we want to save that, but we want to save them in descending order. So that'll be all even numbers and 0. So it returns 4. Actually, it returns 0, then 2, then 4. But we're told to show our results in descending order. So rather than 0, 2, 4, which is the natural order when it selects number, it does it as 4, 2, 0. And there it is. And this is the code as mentioned here that actually runs that particular query. So again, the process described above is deferred execution. The query isn't executed when it's defined. It's defined way up here. It's not executed until later down here. If a query isn't executed when it's defined, it's stored in a query variable. Like what? Like number list. If a query requires access to the individual elements, all right, then an immediate execution occurs. In this case, the query expression is not saved to a query variable. All right, so let's take a look here at query expressions. All right, so as mentioned right here, to identify the source of data for a query, you use the from clause. All right, and basically it's saying, where are you getting your information from? It could be a database table, it could be an array, it could be a list, etc. And as they mentioned there, the first example shows how to use the from clause with an array. All right, the second statement defines the query expression, which is stored in a query variable named sales list. Then a for each loops through and adds all of them up. So there it is. So right here, we've got this new array with 1, 2, 3, 4 values in it. So sales total sub 0, sales total sub 1, sales total sub 2, sales total sub 3. Then we're saying go in there and select all the sales. Then we've got a sum, and we put that into the for each loop, which says var sales in sales list, and then just add them up. So the sum will contain 1286.45 plus 2433.49 plus 2893.85 plus 2094.53. All right. Here's a little bit more complex example. This uses, as it says, a generic list of invoices as the data source. So these are the individual components that are in here. And we're telling it to go through. And again, we are telling it to add all these invoice totals. So again, the from clause, as mentioned here, identifies the source of data for a query and declares a range variable. So it's letting us know our range. What do we want to do here? If the range variable and the iteration variable refer to the same element, you should give them the same name because it'll make it easier to understand. All right. The from clause, as it says, must be the first clause in a query expression. The final clause must be a select or group clause. You can use a where statement to filter. Now, if you remember the example I showed you before, we used a where statement to filter. We didn't want every state listed. We only wanted what? There would be West Virginia, Wisconsin, Wyoming, and if I'm missing any, I don't know. So the where clause lets you filter data. The condition is coded as a Boolean expression that can contain one or more relational or logical operators. So when you start looking in here, what? Where sales greater than 2,000? So we lost one of the sales we had earlier. Where the invoice total is greater than 150, and you can see again that they all are. All right, you can also sort things by using order by. Now, unlike the way that this is done when you use SQL, the structured query language, order by is one word. By default, it orders things in ascending order. You can say order by something, then ascending, or you can just say order by because it's the default. But if you want it in descending, you must specify after order by and then the field name the word descending. All right, and there are some examples here. So again, order by lets you specify how the results are sorted. You can specify one or more columns in this clause. Okay. As it says, so far the queries you've seen in this chapter have returned entire elements of a data source, but you can also return just selected fields. To do that, you can code the select clause as it's shown in here, where you just put an expression name. All right, so rather than saying select and bringing back everything, we're just bringing back one thing. Now, when you do this, as mentioned right here, a query that returns something other than the entire data source is known as a projection. All right, and again, there are a couple of examples in here. So when you look at this, the way that this list is set up, this is the key, there's the value. Key, value, key, value, key, value. And we're saying that what we want in here are just the keys, so just the names, but the value has to be more than 2,000. So we skip Anderson, we show Menendez, then we show Thompson, then we show Wilkinson. And that's exactly what we get here. So the select clause, as it says, indicates the data you want to return from each element of the query results. A query that returns something other than everything that you asked for is called a projection. To return two or more fields, you code an object initializer within the select clause, and that's shown right there. Now, sometimes what happens is you've got the data, but the data has to come from more than one source. For instance, imagine that I had a table, and in that table, it had a list of people's names, and it had their first name, their last name, their address, their city, and their state. But their state was just their abbreviation. So for Missouri, it would, of course, be MO. All right, well, just say those 5 fields. Then I had another table, and each one of those tables, there'd be 50 entries in those tables. There'd be 2 fields. The first field would be the state abbreviation. The second field would be the state name. All right. So if my boss came in and said he wanted a listing of all the people who worked for us in the city and state and address where they lived, we'd have to grab the information from 2 different data sources. To do that, you do what's called a join. All right, and it can look pretty ugly. So from this table in here, do this, join this, and it has to have a field in common. The name doesn't have to be the same, although it normally is, but the type and size must be the same. All right. Now, they're joining 3 different tables here, and as it says, once the 3 tables are joined, you can refer to fields from any of the tables in the query expression. So now everything is available. When you start working with joins, it gets pretty ugly. And we're going to do this. We're actually going to start looking at this in the next chapter. So, as mentioned here, the join clause lets you combine data from two or more data sources based on matching key values. The query results will include only those statements that meet the conditions specified by the equal operator. You can extend the syntax to join as many tables as you want to or need to join. All right. So let's talk about method-based queries. As it says earlier in the chapter, you learn that the query operators are implemented as extension methods, and you can call these methods directly rather than using those clauses that we've been talking about. So this is how you do that. All right. You will do a lot of work with link methods for query operations in the AWD 1115 database-driven website development class. That's not a warning. That's not a threat. It's just a statement so you know that. All right. So it says here the first example shows us how this works. It uses 4 extension methods. So let's look at the example. So notice we were using the where clause. Now it's the where method, capital W. We were using order by. Now it's the order by method. And there's an order by descending. And if you've got multiple, then by, etc. Select is now select paren paren. And join is now join paren paren. When we do this, we end up using typically, all right, we end up using lambda expressions. Now there's 2 ways that you can do this. All right. You'll notice here we do have lambda expressions. So the invoice list, we're running on there a where, which is going to give us only the totals greater than 150. Then we're doing an order by customer ID. Then, and so that'll be an ascending order. Then in descending order, we'll do it by invoice total. And that'll select all the customers, IDs, and their invoice totals based on that. Now that might not have been easy to understand, but again, we are going to be going over this. All right. So C#, as it says, uses extension methods to implement the standard query operators provided by LINQ. To code a method-based query, you use lambda expressions, which consist of an unnamed function that evaluates a single expression and returns its value. That value could be nothing if nothing meets the criteria. It could be one thing. It could be many things. When you join 2 or more data sources, you create an anonymous type that includes the fields required by the query. Then any of these extension methods that follow refer to that type. If you don't need to include all of the fields, you can just code a select to create a new anonymous type with only the fields that you need. All right, some additional LINQ methods. Now, when you look at the first 5 here, count, average, sum, max, and min, those are referred to as aggregates. They literally are designed to return one thing. All right? The count gives you a count of everything that meets whatever you asked for. The average will basically do a sum and divide it by the count. All right? The max will give you the biggest one, the min the smallest one. Then notice what else is here. You've got one that says first. That gets the first thing that comes back from a query. You quite often don't use first. Rather, you might use first or default. Because if I put in there, for example, show me all the people who make more than $1 million, and there aren't any, there's nothing to return. So sometimes you, instead of using first, you use first or default and just set the default value to null. Single should get the only, all right? It should only return one thing. So a lot of times when you use single, you use it on something like an ID. because if every record has its own ID, that should work. If it doesn't find anything, though, it may throw an exception, so you'll typically use single or default. Skip will allow you to skip a certain number of records. All right. Take will allow you to grab a certain number of records. And toList, as it says, creates a list object from the results in the query. This won't make a lot of sense until we actually are going through and doing some of this stuff. And again, we will do some programs in this. All right. All right. And the chapter ends with this customer invoice application that uses generic lists. So this is the interface. All right. You'll notice that some customers, such as Sarah Chamberlain or Kathy De La Fuente, have more than one invoice. Most of these customers have only one invoice. But what we've done is we put these together. So rather than having the name Sarah Chamberlain 3 times in here or the name Kathy De La Fuente in there twice, we've taken all the information, that being the invoice ID, date, and total. We have taken those, all right, and put them right after the name. So as it says here, the customer invoice form uses a list view control. And don't worry if you don't know what a list view is. We will hit on it in a lot of breadth and depth of coverage. I look at a list view as basically kind of showing me the equivalent of like a spreadsheet, but with database information. All right. And they show you the code, which may make some sense to you, may make very little sense to you, but we'll spend some more time going over it at a later time. So as it says, the link query used here makes it easy to include data from 2 different lists. Without link, you'd have to code your own procedure to get the information from one of the lists. The link query also makes it easy to sort based on 2 fields. All right. It says the code for the invoice and the customer classes is the same as what was shown earlier, and the invoice and customer data are stored as text files. However, as it says, it could have been any data source, like a binary file, a database, or something else. Now that's it for this chapter. We went through it quickly. That's it for this section, which was Chapter 17 on File I/O and Chapter 18 on Link. The next section, the last one of the book, Chapters 19, 20, 21, and 22, are all on database programming. Chapter 19 is an introductory chapter which introduces you to concepts and terminology. I'm going to handle this a little different from what's in the book. Then Chapter 20 will talk about ORM, which is known as EF Core, which again is something you will use in the AWD 1115 class in your 4th semester. Finally, the last 2 paragraphs on the page. Occasionally, you'll want to write your own data access code. So you can write code that works with ADO.NET directly, and that's Chapter 21. And in Chapter 22, which will finish the book, we learn how to use the grid view. All right, so the first thing we'll go through is Chapter 19. Not a particularly long chapter, all right, but I'm going to spend most of the time in here, very little on this intro to client server systems, but we're going to look at this database that they have in here, and I'm going to actually bring it up, and I'm going to bring it up not using the database structure that they have, but using a different one. I'm going to introduce a tool to you. Why? Because it's at least a semi-GUI tool, and I'm hoping it'll help your understanding of this. So I'm going to come right back and go over Chapter 19 next in just a couple moments.